One.
Hey guys, Reinventing the Periodic Table by Abram Alcaraz, Alex Rodriguez, and Ben Vinson. Here's the periodic table that we all know and love. This is what we use in all of our classrooms, and we're going to change that. The history of the periodic table. The idea of elements have been around since 300 BC, and in 1649, Henning Brand discovered phosphorus, a new element. In 1817, John Wolfgang, I'm not saying that last name, proposed sorting elements by their atomic weight and triads. In 1869, 63 elements have been discovered. Wow. In the same year, Dmitry Mendeleev also invented the first edition of the periodic table, which we all know. Mendeleev proposed the idea that we should sort our periodic tables with periods, rows, and an idea called groups, these vertical lines, so we can all understand similar elements work similarly.
So what you have before you now is what the Mendeleev's table would have looked like back around 1869. As Abram mentioned, only 63 elements were known, so a lot smaller of a knowledge base that we have now. So you ask, why circular periodic table? First of all, it has a cleaner aesthetic. Second of all, it offers a different perspective compared to the normal traditional rectangular table that we all know. It's easier to see relationships between the elements depending on how it's placed. And it's also, graphic designers can use it, as ideas. Cool to kind of compare and contrast between the two. So those are some reasons you might do the circular table.
Okay, so our design was designed using Fusion 360, and the inside of the circle starts with hydrogen, which starts with the atomic number 1 and works its way outwards in a counterclockwise motion. And then the outer two rings of the circle represent the methanide series, which are separated in the rectangular table. There are a bunch of other nuances to our design, such as color-coded sections and a variety of other things that we'll explain in the next slide. So here's our design. It is our circular periodic table. As you can see, on the right-hand side, hydrogen at the topmost layer is where we start off from, and then we go counterclockwise. It's going to be the same counterclockwise motion for the rest of the periodic table, and I tried my best to separate out the sections where it's like there are large gaps. In the next, it's very clear, you can see. You see how between lithium, beryllium, and boron and carbon, there is that huge gap, so I tried to represent that in my model. As you can see with that layer, there's a larger gap in the design. Now, I decided to do a bookmark for the lanthanide series because it seemed like the best fit to tie in both the the normal periodic table and the lanthanide and actinidide series, and I felt like it was the best design choice. And then here is the standard periodic table. As you can see, I decided to connect where lanthanide and actinidide connect to the series at the bottom. That's where the placeholder is. That's where the bookmark is, because they're technically in both series at once. And you can see a bunch of different similarities in the both designs. Thank you for listening to our presentation, and I hope to see you soon. Here are our sources.
Thanks, guys.
Thank you.